Hey everyone, welcome back to our Calculus 3 class notes. We are now on page 88 and I'm going to look at example 78. Here I'm going to evaluate another what's called iterated or double integral. And I want to evaluate over the region where, so what is this telling me? This is telling me that x is going from 0 to 1 and y is going from 0 to 1. So again, we're integrating over a rectangular region in the xy plane and we're integrating the function y over 1 plus xy. So I specifically did not draw this function this time or attempt to. That's a more complicated looking function. And right now I'm just making sure you understand the integration properties here. And also that always remember this is if this were all positive over this region, then it would give me a volume underneath this surface down to the region. If it becomes negative at some point, then it's a net signed volume, just like we had net signed area for the integral of a single function over an interval on the x-axis, okay, or the y-axis, either way. Okay, so now integrating something like this, if I'm going to integrate with respect to x, what I need to do is I have a 1 plus xy. Y is thought of as a constant, so I need to think of this as a substitution problem. So don't forget that all of your integration techniques that you learn in Calc 2 will still apply. You will need to do integration by parts. You'll need to do substitution. You'll have a couple of trig substitutions you'll need to do. So all the techniques that you learn in Calc 2 we will probably need to apply here as well. But this one's a substitution problem. So we're going to let u equal to 1 plus xy. Then remember we're getting things in terms of x, so we're treating the y as a constant. So the derivative of u, right, with respect to x only is 0, and then the derivative of x times y is y. So you get du is y dx. Okay, so there's my y dx, which becomes du, and then I have u in the denominator. So and I don't usually change my limits of integration once I do a substitution. What I will do is write that technically, just so the reader would understand what's going on, these are still in terms of x now. They're not in terms of u, so I'll write x equals 0 to x equals 1. Some people will say change the limits of integration here, and either way is fine. You can change the limits of integration to be in terms of u, or you can leave them that way and then just evaluate it once you get everything back in terms of x, which is what I like to do. So the integral of du over u is natural log of the absolute value of u. Now this is from x equals 0 to x equals 1, so it's a natural log of u, which is 1 plus xy. From x equals 0 to x equals 1, so if I plug in x equals 1, I get the natural log of 1 plus y. Minus plugging in x equals 0, natural log of 1. Now natural log of 1 is 0. And also, since y is only varying between 0 and 1, I do not need the absolute value signs around natural log of 1 plus y, because this will always be positive when y is between 0 and 1. So I can drop those absolute value signs, and I get that it's equal to the integral from 0 to 1 of natural log of 1 plus y dy. Now, hopefully in Calc 2 you learn and you remember that anytime I see a natural log inside of a function, that has to be u. Okay, either it's a substitution problem or it is an integration by parts problem. Now this one's an integration by parts problem, because if I did du, there's nothing to have that go away. So integration by parts means I let u equal natural log of 1 plus y, and then dv is what remains, which is just dy. So u, I got to get the derivative of u with respect to y, so this should be du is 1 over 1 plus y. There should be a dy here, sorry I didn't write that. Du is 1 over 1 plus y dy, and v is the integral of 1 dy, which is y. So the formula for integration by parts said it's uv, so y times natural log of 1 plus y. I'll evaluate that from 0 to 1, minus the integral from 0 to 1 of v du. So v is y, and du is 1 over 1 plus y dy. So it's y over 1 plus y dy. Okay, now this then is a substitution problem. I'm going to let u equal 1 plus y. Now that in turn means that y will be u minus 1. So this y becomes u minus 1. 1 plus y is u. And the reason I need to do that, to flip these around, is because this one can be simplified, whereas this cannot be simplified. Right? Y over 1 plus y cannot be simplified, but u minus 1 over u can be. Okay, evaluating this guy, you get 1 times the natural log of 2, so that's just natural log of 2, minus 0 times natural log of 1, 0. So that's natural log of 2. Now I have my integral in terms of u, and I can simplify this to be u over u, which is 1. minus 1 over u. So I have 1 minus 1 over u du. And then that integral is u, and the integral of 1 over u is natural log of u. So it's u minus natural log of u. Evaluate from y equals 0 to y equals 1. So now we need to put u back in. So that's 1 plus y minus natural log of 1 plus y from 0 to 1. So when I evaluate that, I get 2 minus natural log 2 minus 1 minus natural log 1. Natural log of 1 is 0. End up with 2 minus 1, which is 1, minus natural log 2. But I have a minus sign in front of it, so that's minus 1 plus natural log 2. So the final answer is natural log 2 minus 1 plus natural log 2, or 2 natural log 2 minus 1.